This video is part of Firm Theory Cost. In it, I will present cost minimization. Recall from the circular flow model that firms operate in both the market for goods and services, as well as the market for factors of production, also known as inputs. Firms buy the inputs like land, labor, capital, and entrepreneurship in the factor market, and in purchasing these inputs, they incur a cost. This video looks at how the firm can decide the cheapest combination of inputs that would be needed to produce some level of output. Do remember, though, that firms are buying the factors in order to produce their goods and services so they can sell those goods and services in the goods market. But again, this video looks at an objective of cost minimization. How does the firm choose its inputs in order to minimize the cost of producing some level of output? This is necessarily a long-run analysis because we're allowing the firm to choose both input levels, which implies that both input levels are variable. One of the tools we have in the long run to graphically describe and mathematically describe cost is an isocost line. As you'll see, an isocost line is very similar to a budget line. An isocost line is going to summarize all the different combinations of inputs that have the same expenditure or the same cost. Usually we assume in a two-input model that these two inputs are labor and capital. Let's define the wage rate, or W, to be the per unit price of labor. Therefore, the cost of labor is W, the per unit price, times L, the number of units of labor. Likewise, capital has a per unit price called the rental rate, denoted R. We think of the price of capital usually as a rental rate because a lot of capital can't be bought outright and instead is financed. So we might think of the firm as renting its capital, which is why its per unit price is called the rental rate. If R is the price of a unit of capital and K is the number of units of capital, then R times K is the cost of capital, or how much expenditure the firm has for capital. Cost comes from inputs, and so total cost is the cost of labor plus the cost of capital, or total cost is WL plus RK. The reason why the total cost variable right here has a bar over it is because along an isocost line, cost is held constant or fixed. It might help for graphing to solve this isocost line for capital, given that the convention, just like isoquants, is to graph labor on the horizontal and capital on the vertical axis. To better understand isocost lines, let's compare them to budget lines from consumer theory. We learned in consumer theory that a budget line can be represented by the equation income equals the per unit price of X times the amount of X plus the per unit price of Y times the amount of Y. Now we're seeing in firm theory that the isocost line can be written as total cost, which basically represents the firm's budget, equals the per unit price of labor times labor plus the per unit price of capital times capital. When we graph budget lines in consumer theory, we put good X on the horizontal and good Y on the vertical axis. In firm theory, when we graph isocost, we put input labor on the horizontal and input capital on the vertical axis. The budget line usually is represented by a downward sloping line, the intercepts of which are income over the price of X and income over the price of Y. Each intercept represents the most amount of that good that the consumer could afford if all he bought was that good. So for example, if the consumer only buys good X with his I dollars at a price per unit of P of X, he can afford I over P of X units of X. In a similar way, usually the isocost line can be represented by a downward sloping line, the intercepts of which are total cost over R for capital and total cost over W for labor. Total cost represents how much the firm is spending at every point along this isocost line, or the firm's budget, and W represents the per unit price of labor, and so total cost divided by W represents how much labor the firm can afford if all it buys is labor. In consumer theory, we learn that the slope of the budget line in absolute value can be called the marginal rate of transformation, which represents how much of good Y the consumer would have to give up if she bought one more unit of good X and still had the same amount of income, and was calculated by the price of X divided by the price of Y. In firm theory, the slope of the isocost line in absolute value can also be called the marginal rate of transformation, will tell us how much of input capital the firm would have to give up if it bought one more unit of labor and had the same total cost, and can also be calculated by taking the price of labor and dividing it by the price of capital. Now on to the topic of the video, which is cost minimization. For cost minimization, we're looking at a firm whose objective is to minimize the cost of producing some fixed level of output. The objective, again, is to minimize cost while holding output constant. Visually, what we have here is a firm whose constraint is that it has to be on some isoquant curve, and maybe that's because the firm has a quota, a production quota that it has to meet, or maybe because this level of production represents the profit maximizing level. And so given what the firm knows to be the profit maximizing level of output, it now wants to figure out how to produce that level of output at the lowest possible cost. But the constraint is that there's one isoquant curve the firm has to be on, and then the objective is to find the lowest of the possible isocost lines. So we're moving to the lowest isocost line while staying on the same isoquant curve. Now, this is exactly the opposite problem that we looked at in consumer theory. We call this the dual problem. Remember, in consumer theory, what we had was an objective of utility maximization with a constraint that the consumer had a fixed budget or a certain level of income. So in consumer theory, there was one budget line that the consumer had to be on, and given that constraint, the consumer was searching for the highest possible indifference curve that they could attain. So in firm theory, we're moving to the lowest possible isocost line, and in consumer theory, we were moving to the highest possible indifference curve. So those are definitely different goals and constraints. However, what is exactly the same in both problems is that the optimal bundle is going to be, once again, this point of tangency. Regardless of whether we're looking at cost minimization or utility maximization, we're going to see that the solution is at a point of tangency between the curve and the line.